I want to conclude our discussion on the quadratic formula by looking at another word problem. And that word problem reads as: an object is thrown downward with an initial velocity of 19 feet per second. The distance d it travels in the amount of time t is given by the equation d equals 19t plus 15t squared. How long does it take for the object to fall 50 feet? So we have a distance equation, and we can calculate the distance if we were asked to calculate the distance at a particular time. It's just a matter of plugging in, like let's say we want to know how far is the object after 1 second. We can go ahead and replace t in both terms with 1, and then find that value, and that would give us the distance after 1 second. Likewise, if we want to calculate it for 2 seconds, 3 seconds, 4 seconds. But this problem is kind of asking us the reverse. What we're given is a distance, and we want to find the time that corresponds to that particular distance. So they want to know how much time does it take for the object to fall 50 feet. So when d is 50, we want to find what t is, 15t squared. So when d is 50, we want to find the value of t. Well, this is just a matter of solving the quadratic equation for t, and once we find that time that corresponds to this 50, we would know what is the time that corresponds to a distance of 50 feet. To solve this quadratic equation, we need to go ahead and take everything over to one side and set the other side equals to 0. So we subtract 50 from one side. So when we subtract 50 from this side, we're going to end up with 0 is equals to 19 t plus 15 t squared minus 50. And you can, again, put this equation in descending order. And if you didn't want to put it in descending order, you just need to be mindful of what the a, b, and c values of the equation is. A is always the coefficient of the term that has the degree 2. So a is at 15. B is always the coefficient of the linear term, or the term with that degree of 1. So b is the 19. And c is always the constant term, which is just that term right there, which is negative 50. And then after we know our a, b, and c values, it's just a matter of plugging into the quadratic formula. Now I'm using t here as opposed to x as we normally would use, because the equation has the variable t in it, and we're trying to find the time. So t is being represented here as opposed to x. So t is equals to minus whatever b is, so minus 19 plus or minus the square root of 19 squared minus 4 times a is 15, c is negative 50, all over 2 times a, which is 15. When we simplify that further, we have 19 plus or minus the square root of, well, 19 squared is 361, and then we have this business over here, which gives us a result of 3,000. So this is 361, negative 4 times 15, that's 60, 60 times 50, that's 3,000. So plus 3,000 here, all over 30. Then when we simplify this further, we'll have negative 19 plus or minus the square root of 3,361, all over 30. And then when we simplify it further, we have negative 19 plus or minus, well, the square root of 3,361. Well, 3,361 is not a perfect square, but I can take the value of that using the calculator, and that will come out to 57.97. So this will be 57.97 all over 30, and at this point you can break up your two solutions. So this will be negative 19 plus the 57.97 over 30, and this one over here will be negative 19 minus the 57.97 all over 30. And if you simplify this here, we would get, this is going to be what, 30, like 38.97 divided by 30, so 38.97 divided by 30, which gives you a result of approximately 1.3 seconds. So 1.3 seconds over here. Now if you look over here, this answer is going to come out to a negative value, some negative value. So negative value. And of course, we cannot have negative times. Keep in mind what your answers are representing. Your answers are representing time, and you cannot have a negative time, so we would discard this value over here since we cannot have negative time. So this will be our true value. So the distance, at a distance of 50, for that object to fall 50 feet, it would take 1.3 seconds in order for the object to fall 50 feet. Thank you.